We live on a giant ball of rock and water called Earth. This planet, our home, is unique in so many ways. It's not just the air we breathe or the water we drink that makes it special, but also the invisible forces that govern our daily lives. One of the most important of these forces is gravity. It pulls us towards its center with an invisible force called gravity. This force is what keeps everything anchored to the ground, from the smallest pebble to the tallest skyscraper. This force is what keeps us grounded. Without it, we would be floating aimlessly, unable to perform even the simplest tasks. Imagine trying to walk, eat, or sleep without the reassuring pull of gravity. It's why we don't float away. Gravity is the reason why when you jump, you come back down. It's the force that brings an astronaut back to Earth after a mission in space. We measure Earth's gravity as 9.8 meters per second squared. This measurement might sound technical, but it essentially tells us how fast objects accelerate when they fall. That's a bit of a mouthful, but it basically means things fall really fast. If you drop something, it will speed up as it falls, reaching the ground quicker than you might expect. Think about your daily life. Every step you take, every move you make, is influenced by gravity. From the moment you wake up and get out of bed, to the time you lay down to sleep, gravity is at work. Gravity affects everything you do. It keeps your feet on the ground as you tie your shoes, and it holds your papers down as you work at your desk. It dictates how high you can jump. Athletes train to overcome gravity's pull, but no matter how strong they are, gravity always brings them back down. It determines how far you can throw a ball. When you throw a ball, gravity pulls it back to the ground, dictating its arc and distance. It even influences the way buildings are constructed. Engineers and architects must consider gravity when designing structures, ensuring they are stable and safe. Without gravity, our world would be a very different place. Imagine a city where everything floats, where there is no up or down. Life as we know it would be impossible. Gravity is a fundamental force of nature. Scientists study it to understand not just our planet, but the entire universe. It's a key to unlocking the mysteries of space and time. It's what holds our atmosphere in place, allowing us to breathe. Without gravity, the air we rely on would drift away into space, leaving us unable to survive. It drives the tides, moving vast amounts of water. The gravitational pull of the moon and the sun creates the tides, which are essential for marine life and coastal ecosystems. It's a powerful force that shapes our planet and our lives. From the tallest mountains to the deepest oceans, gravity influences every aspect of our world, making it the incredible place we call home. Our moon is Earth's closest neighbor in space. It's much smaller than Earth and it has much weaker gravity. In fact, the moon's gravity is about 1/6 of Earth's gravity. That means you'd weigh much less on the moon. Imagine feeling lighter than a feather. If you were to visit the moon, you'd notice the difference right away. You could jump much higher and farther than you could on Earth. This is because the moon's weaker gravity doesn't hold you down as strongly. Walking on the moon is a unique experience. Astronauts describe it as bouncing along. The lower gravity takes some getting used to. Mars is another planet in our solar system. It's the fourth planet from the Sun, and is often visible to the naked eye from Earth. Known for its reddish appearance, Mars has fascinated humans for centuries. Ancient civilizations named it after their gods of war, due to its blood-red color. It's often called the Red Planet because of its rusty color. This distinctive hue comes from iron oxide, or rust, on its surface. The landscape is dotted with vast plains, towering volcanoes, and deep canyons, making it a geologically diverse world. Mars is a bit bigger than the Moon, but it's still smaller than Earth. With a diameter of about 6,779 kilometers, it's roughly half the size of our planet. Despite its smaller size, Mars has the largest volcano in the solar system, Olympus Mons, which stands nearly 3 times the height of Mount Everest. And, just like the Moon, Mars has weaker gravity than Earth. This lower gravity, about 38% of Earth's, means that objects weigh less on Mars. For astronauts, this would mean less strain on their bodies, but it also presents unique challenges for movement and daily activities. Mars has about 1/3 of Earth's gravity. This reduced gravity affects everything from how high you can jump to how much muscle and bone density you might lose over time. Scientists are studying these effects to prepare for long-term human missions. This means you'd still weigh less on Mars than you do on Earth, but you'd weigh more than you would on the Moon. For example, if you weigh 100 pounds on Earth, you would weigh only 38 pounds on Mars. This difference in weight can significantly impact how we design equipment and habitats for future explorers. You could still jump pretty high on Mars, but not as high as you could on the Moon. The lower gravity would allow for more extended leaps and bounds, making movement both easier and more challenging in different ways. Training for these conditions is crucial for astronauts. Scientists are very interested in Mars. They are conducting numerous studies and simulations to understand the planet better. These efforts include analyzing soil samples, studying the atmosphere, and even simulating Martian habitats here on Earth. They believe it may have once had conditions suitable for life. Evidence suggests that ancient Mars had liquid water on its surface, which is a key ingredient for life as we know it. Discovering past or present life on Mars would be one of the most significant scientific findings in history. Understanding how gravity works on Mars will be important for future human missions to the Red Planet. As we prepare for these missions, learning how to live and work in Mars's unique environment will be crucial for the success and safety of astronauts. The Red Planet holds many mysteries, and exploring its gravity is just the beginning of our journey. Beyond our solar system, there are countless other planets. Some of these planets are called super-Earths. These planets are larger and more massive than Earth. As you can guess, super-Earths have stronger gravity than our planet. Imagine a planet with twice or even 3 times the gravity of Earth. That's what it would be like on a super-Earth. Everything would feel much heavier. Just walking around would be a challenge. The intense gravity of super-Earths would have a profound impact on life as we know it. Plants and animals would need to adapt to survive in such an environment. Even the shape of mountains and landscapes would be different. Section 5. Gas giants crushed by gravity. Gas giants are the behemoths of our universe. These colossal planets, primarily composed of hydrogen and helium, dwarf the rocky planets like Earth and Mars. Their sheer size and mass make them some of the most fascinating objects in space. Planets like Jupiter and Saturn are gas giants. They are so large that they could fit all the other planets in the solar system inside them, with room to spare. Their immense size is matched only by their powerful gravitational pull. They are enormous balls of gas with incredibly strong gravity. This gravity is so intense that it shapes the very structure of these planets, creating swirling clouds and storms that can last for centuries. The gravity on a gas giant is strong enough to crush anything that gets too close. This immense force can pull in objects from millions of miles away, drawing them into the planet's atmosphere where they are obliterated. Imagine a gravity field hundreds of times stronger than Earth's. This means that even the strongest materials known to humanity would be unable to withstand the pressure. That's what you're dealing with on a gas giant. The atmosphere is a turbulent mix of gases with winds that can reach speeds of over 1,000 miles per hour, driven by the planet's rapid rotation and intense gravity. If you could somehow stand on the surface of a gas giant, which you can't because they are made of gas, you'd be instantly flattened like a pancake. The crushing force would be beyond anything we can experience on Earth. The gravity of gas giants plays a crucial role in our solar system. They act as cosmic guardians, their massive gravitational fields influencing the orbits of other objects and protecting the inner planets from potential collisions. These massive planets act like gravitational vacuum cleaners, attracting and deflecting asteroids and comets. Without them, the inner solar system would be a much more dangerous place, with frequent impacts that could threaten life on Earth. Section 6. Zero gravity, floating in space. Have you ever seen astronauts floating inside the International Space Station? They look like they're having fun, right? Well, they're experiencing what's called zero gravity or microgravity. In space, far away from any planets or stars, there's no force of gravity pulling you down. Without gravity, your body behaves in strange and fascinating ways. You float effortlessly. Liquids form into perfect spheres. It takes a bit of getting used to. While it looks fun, living in zero gravity for long periods can have an impact on the human body. Muscles and bones can weaken without the constant pull of gravity. Section 7. A world transformed. What if Earth's gravity changed? Let's imagine for a moment that we could change Earth's gravity. What would happen if gravity suddenly became stronger or weaker? It would be like something out of a science fiction movie. If Earth's gravity increased, everything would become heavier. Buildings would need to be stronger to support their own weight. People would have to adapt to the increased strain on their bodies. We might even evolve to be shorter and stockier. On the other hand, if Earth's gravity decreased, we'd feel lighter. We could jump higher and run faster. But there would also be consequences. Our atmosphere might start to drift away into space. That wouldn't be good. Section 8. Gravity's impact from buildings to our bodies. Gravity isn't just something we learn about in science class. It affects our lives in countless ways, from the way we build our homes to the way our bodies function. Architects and engineers have to consider gravity when designing buildings and bridges. They need to make sure their structures can withstand the constant pull of gravity. That's why skyscrapers have deep foundations and strong support beams. Our bodies are also shaped by gravity. Our bones and muscles are designed to support our weight and allow us to move around. Even our internal organs are affected by gravity. Section 9. Gravity's grand design shaping the cosmos. Gravity is one of the fundamental forces that govern the universe. It's what holds planets in orbit around stars. It's what causes galaxies to spiral and collide. Gravity is the master architect of the cosmos. From the smallest atoms to the largest superclusters of galaxies, gravity plays a role in shaping the universe we see around us. It's a force that's both awe-inspiring and essential to our existence. So the next time you jump up and down or see an apple fall from a tree, remember the invisible force at play: gravity. It's a force that connects us to our planet, to our solar system, and to the universe itself.